As you know, ladies and gentlemen, that we are going now with chapter 6, which for interpretation of the EKG strip. And of course, we had all of this before, but let us review together. So first of all, before starting doing EKG for any person, of course, Mark, you have to evaluate your patient. Maybe your patient is acute condition, or he is in like acute emergency. So we have to first, before you start the EKG, like I told you, you have to look at your patient, and we have to read the strip from the left to the right. And for our study, starting from now, we have to follow 5 steps. We have to follow 5 steps. And these 5 steps has to be like going in order. Okay, Al-Haja? It has to be going in order. This means 1, 2, 3, 4, 5. I'm not going to jump to 3 before 2 or something like that. No, we have to go in order. So all what I need from you to write down these 5 steps and put it in front of your eyes or in front of your screen so you can answer any strip in the world. Okay, let us go step by step to make our job easy. What are the 5 steps? Number 1, I need you to save this slide. Number 1 is, what is the heart rate? As I told you, ladies, all of this information will be given to you by the advanced machine right now. Everything is now with advanced and the computerized machines. So, but in the exam and the certification exam, they are not going to provide you with any aids, except you have to answer all of this by yourself. So, the first question you have to answer, Al-Haja, is what is the heart rate? And we learned something. Yes, very good. You are so smart. Al-Haja said that I will count how many are in 6 seconds and multiply by 10. I will get the heart rate. Excellent job, Al-Haja. After that, we are going to mention it is regular or not, which is the heart rate. What we mean by regular? It is like I told you, like this, regular, like rhythmic, like the pendule of the clock, regular or irregular. Then the third step is to comment mark on P wave. What is the P wave? We mentioned, Stephanie, that the P wave is first upright, smooth wave precede QRS, right? This is the normal. We mentioned this before. Repeat again, CD. Positive or upright, smooth wave precede QRS. That's it. So this is the normal P wave. What about the PR interval? We just mentioned that the PR interval should range between 0.12 to 0.20 seconds. So all of these are normal. What about the QRS complex? The QRS complex, Stephanie, has a time which we mentioned it is less than 0.12 seconds. If you answer these 5 steps, you can say what is wrong or what is correct. It is safe or unsafe. It is perfect or not perfect EKG. Okay? So from now, I need everyone to save these 5 steps. When we are going together to analyze any EKG, don't jump. I need you to go one by one. If I ask you, Diana, let us read this step, Diana is smart. We'll say that First, the heart rate is and count and multiply by 10. Number 2, it is regular or irregular. Comment on P wave. PR interval is whatever the measurement she got. And if it is like within the range, it's okay. And the QRS, she found that it is also within the normal range. She will report to me that this is normal EKG, right? So this is how we go in advance of our study, and this should be very clear. Now we have two important issues. Actually, the atrial rate, what we mean by atrial rate, the number of or the atrial contraction. How can I know the number of atrial contraction? By counting the number of P wave. Makes sense. What about the ventricular contraction? It means I count the number of QRS, right? So it should be what? Should be equal. Like we mentioned, this should be equal, but we will find something variation in the future which is not equal. So it will make some, or this means there is a problem with the heart. So this means what, El Haja? That for every P wave, I have to get 1 QRS. Make sense?
Yeah.
Very good. So what is the atrial rate? Sometimes we get a disease like having many P's, but not the same number of like QRS complex. So this number 1. Number 2, we are familiar about this situation. We normally know, Mark, that when you count the pulse of any patient and you find that it is normally the range between 60 up to 100 beats per minute.
Yeah.
So 70, 75, 80, 90, I will say it is within normal. But if it is more than 100, and I need you from now to put this expression in your mind. From now, any number above 100,
Tachycardia.
tachycardia, perfect.
Mm.
Any number less than 60, it will be
Bradycardia.
excellent, 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 excellent. Okay, and how we determine the heart rate? The heart rate, like I told you on lab, that we go by the 6-second methods, and we are familiar about why we go by 6 seconds, and we learned how to, yes, correct, Al Haja, yes, that we multiply the number of QRS, which is ventricular contraction, by time 10, and you will get the heart rate. This is very easy method, very fast, very easy, but it is not accurate 100%. Like you mentioned, and you notice when we count it by the practice, we find that the heart rate is like 70, and the machine tells us it is like 69. It is almost. Okay, so this 6 method, if I count how many are in 6 seconds and multiply by 10, it is okay, but it is not accurate. Okay, so let us have here example. This is like 30 big square mark, and when we count the number, we find that we have like how many? Can anyone count with me? How many QRS?
8.
8. So the heart rate is
80.
80. We multiply 8 by times. This is very easy. Okay, we practice on this actually previously. And the second method, it is the same but getting more accurate. What is the second method? I count how many big square between R and R. say I found that I got like 4 big square. We mentioned that in 1 minute, we have 300 big square. You remember? We had 300 big square. So if I divide 300 by the number of big square between R and R, I will get the heart rate. The last issue is, Irene, we mentioned that if I count to get more and more accurate, if I need more accuracy like the machine do, I will count how many small boxes between R and R, and we know that 1 minute contain 1500 small box. So I do the same job. I will divide 1500 by the number of small boxes between R and R. I will get exactly what is the heart rate. Any questions? Yes.
Can you repeat that again?
Okay, I repeat this again. We have 3 methods to count the heart rate. The one which we learned together at school, we count how many QRS, or roughly speaking, to say R, in 6 seconds, and we multiply by 10. The second method is to count how many big square between R and R, and divide this number by 300 big square. The third method is to count how many small square between R and R, and we divide it by 1500. And we explained before from where we get 300 big square and from where we get 1500 small square. Let us get this example. I need everyone, if you don't have background noise, open your mic. Serena, are you online?
Yes, but my kids are here, so you can probably hear them in the background. So I'll turn my mic off.
Okay. Sidi.
Yes, I have my son here. So.
Okay.
I
Zara.
have my daughter, Dr. Israel, too.
Okay. Zara.
Hi, I don't know if you can hear anything, but if it's not, then I'll leave it on. There's just some lawn
Okay,
mowing.
I need one to tell me what is the heart rate here. We have 3 methods. We learned 3 methods. So I need everyone be sure how to go by these 3 methods. So who can start with me?
100 beats per minute using the QRS.
How many? How many?
100.
Okay, how you get it?
I counted the QRSs. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I was going to use the other methods, but I can't see the boxes too well.
Very good, very good. So she counted the heart rate by the first 6-second method. She got 100. She got 10 multiplied by 10 equal 100. So this is very good. The second procedure is go by the big square. So let us, or let me help you to start. So the second method is from R to R. So if I go like this, this is R. And this is R. So how many big square? It looks like here 1 and 2, and this is half, and this is half. So almost 3 big square. Very good. So what should I do? I'm dividing 300, Al-Hajja, 300 divided by 3, I will get 100, like what Zahra got. Very good. Let us go by another technique. What is the other technique? Let us go by the small. So let us go here, from here to here, which we call RR. Okay, let us count. 1, 2, 3, 4, 5. So 9. Another 5. 14. Then
16.
3, 17.
17. So small 17. Small boxes, number are 17. So what should I do? I have to divide 1500 by 17. I will get like almost so close to the number of 100, but it is the most accurate. So it will be like 97
88.
something. How many? You got it?
88.
88. Very good. So this step help us for how to calculate the heart rate as the first step. We have 3 ways. Number 1, we count how many are in 6 seconds and then multiply by 10. The second method, we count how many big square between R and R and divide this number by the figure 300. The third method is to calculate how many small square in distance between R and R and divide this by 1500. Then we are going to answer the second step, which is regularity. And all what I need from you is to tell it is regular or irregular. Just this. Regular means what? The distance is almost fixed between R and R. If I find it is not fixed, I will say this is not regular. Let us see. This one is regular or not regular. If I count, if I do,
6.
From a first glance, it looks regular because it looks like the spaces are all equal.
say it again, ma'am.
It looks regular because all the spaces look.
Very good. So the space from here to here is like space from here to here, and like space from here to here. Of course, also this equal to this distance, also equal to this distance, and so on. So I find that R to R almost fixed. Good job, Zar. Okay. Let us look for another one. What do you think? Regular or not regular?
Regular.
Regular. Very good. And this is
Regular.
regular. What is the heart rate here?
60 beats per minute.
How many?
60.
So this is normal?
Yes.
Very
Regular.
good. Very good. Correct answer. Very good. And here also, what is the heart rate?
80.
1, 2, 3, 4, 5, 6, 7, 8. Okay, so 80. Very good. All right. And we mentioned also that the third step is to comment on the P wave. And we mentioned that the P wave is like rounded or smooth, and it is upright, means positive, and it represents the atrial contraction. And we know that this is the P wave. We learned this before. And first of all, we have to be sure that I can get P wave or it is not present. And look here, one P wave present for each one QRS. As I told you, the number of P's should equal the number of QRS. This is very important because in the future we find that the number is not related to each other, and this is like problem with the heart. Then we have to go by the PR interval, and we learned together that the PR interval has a range between 0.12 to 0.20. And let us see. It is constant. This is also important. And diagnosis. Why? Because in second degree heart block, we find that this number, it is not constant. It is coming, increasing and drop, increasing and drop. So it should be constant. So please highlight this one and take notes of it, okay? It should be constant all the way. And here, if I go to practice for the PR interval, I will guide you. All right. So PR interval, we can say that from here, you see the line, or it is fine? You see the green line?
Yes,
Oh.
I can see it.
Well,
Okay, so this is the beginning of P, and here with the beginning of R. Let us count how many small squares. 1, 2, 3, 4, 5, 6. What do you think? Let us count again. 1, 2, 3, 4, 5. Actually, it's 5, not 6. 5. So 5 small boxes equal what?
0.2.
0.2. Very good. So PR interval is 0.2. This normal or not normal?
Normal.
Normal. Very good. You got it, guys? How to count the PR interval, starting from here and starting here. We count the number. We find it is like 1, 2, 3, 4, 5. This is the same. So it is 5 small boxes, and it is constant. You remember? So less than or range between 0.12 to 0.20, and it is constant. So this is perfect heart. You got it? And so on, we are going together. That the QRS, as you remember, the QRS looks like here. And as you see, it should be like less than 3 small square, and it represents the contraction of the ventricle. And if we count the number between the Q and the end of S, and we find that it is less than 3 small boxes, this means we give it name. What is the name? Narrow. Because in the future, we can find it is wide, like we had one of the EKG, if you remember. I don't need to mention the name. Yesterday, on Tuesday, we had one with a wide QRS, you remember? And this wide QRS indicates that she had previous heart problem, and she confirmed this situation before. So this is very important. And after that, we will get also information about the T wave and the U wave, which is very, very, very rare to happen. And we mentioned also that we can get artifact. Like we practice that artifact can come from loose electrodes. Artifact can come as a result of the patient is feel cold, and we got like artifact that the patient has a metal attached to the body, artifact that the patient is talking or moving, all of this, like we had this experience during our lab, that we got some of artifact, and when we correct the situation, we get here, look, we had this before, you remember? This is like what happened before with one of our students that we have, she feel cold, and this cold is like making this fine waves. It is not related to the hard waves. I hope everything is okay for today's chapters 5 and 6. And of course, if you have any question, you are so welcome.
Dr. Israel, can you explain again what the improper grounding is?
I can't hear your voice again. See it
Can
again.
you explain again what like improper grounding?
Improper grounding?
Yes.
Yes. Like we mentioned here, if you look here, you see, just a minute. Look, map, if you look to this strip is like giving this wave. You see these waves? So this waves is like when the patient is feel cold, or the patient is like talking, or improper grounding. What do we mean by improper grounding? We mentioned that we have positive and negative and ground. You remember the outlet has 3 holes, positive, negative, and the third one is ground. Why we have ground? For safety, to absorb any extra voltage or extra charge coming from electricity, so we are not going to have shock. So all the machines going to be attached to the patient has this ground, and this ground help us to be like in safe technique. You got it?
So if it's improper grounding, meaning that the right
We will get
leg is,
artifacts similar to this. If we have
No, but-
improper grounding, we will get artifacts similar to this.
but the improper grounding meaning like the right foot is not correct, or the right
Yes.
foot is not. Okay,
Yes,
that's what I
yes.
was trying.
yes. Any more questions?